Okay, hello guys, and welcome to our event. Welcome to the Golden Week at the Cloud Computing Workshop. So basically here for 3 days, today, tomorrow, and on Sunday. So in order to get your certificate, you have to watch the whole meeting and then do the task that we will send to you at the end of the meeting. So our speaker is Mr. Joe Al-Husseini, graduated from AOU with a BS in Information Technology and Computing and a MS in Information Security and Forensics. He's currently working in managing services at EXEO and has 7 years of professional experience in system and network administration, as well as cloud services. He pursued many certification paths and have the following certification: EC Council Certified Ethical Hacker, EC Council Certified Security Analyst, Google Cloud Certified Professional Data Engineer, Huawei Certified ICT Associate 5G, Huawei Certified ICT Associate Routing and Switching. Mr. Al-Husseini, the screen is yours.
Hello, everyone. Thank you for the introduction.
Thank you.
Okay, so can you see the presentation?
Yes.
Yes. Yes.
Okay, today we'll be talking about an introduction to cloud computing with the main focus on infrastructure as a service. Many of you have heard the trending word today, which is the cloud and cloud computing. It is the most famous subject in IT, along with security. However, many do not clearly know what the meaning of the cloud is and what are the misconceptions about it. The most famous meme we've seen on the internet is, what if I told you the cloud is just someone else's computer? Although this sentence is partially true, it holds many misconceptions. And we'll see together how the cloud is someone else's computer. However, it is not just one computer, and it is not one big entity. However, it covers the entire internet. And we will also see that this raises many interests around security and managing of the cloud. To start with the cloud, we have to start with the definition. So cloud computing is the availability of compute, network, and storage resources over the cloud on demand in a scalable and flexible way with a pay-as-you-go billing system using distributed systems and servers provided by cloud provider. So the main concept that drove the IT sector to go towards cloud computing was virtualization along with co-location. We all know that initially computers were consisting of CPUs, RAM, hard disks, and servers are supercomputers that can execute massive input-output operations and compute operations. So when the need for higher processing power, when the need started for higher processing power, ITs had to figure out a way to give the business what it needs in order to carry out complex operations. And when traditional IT systems were not able to provide these needs, cloud computing and virtualization began to appear. So it all started when the cost of maintaining complex IT infrastructure was so high. So ITs had to start with something called co-location, where they carry their servers and put them in a managed structure, where someone had to take care of the ventilation and the power and the environment that the servers had to be installed in. And virtualization, which we will talk about right now, which gave computers more efficiency in terms of compute power and processing. The term virtualization means that we can use a host computer or a host machine to create another guest machine, which is virtualized, in order to utilize all the resources inside the server. So suppose we have a server with 4 CPUs and let's say 20 gigabytes of RAM. And on the server, we install an application that needs 1 CPU and 1 gigabytes of RAM. This way, we are wasting 3 CPUs and 19 gigabytes of RAM. So the need for virtualization came up so that we can divide this computing power and use many applications and many operating systems on one host or one physical machine. So the needs for virtualization, or the technical terms in this operation, are host machine, host OS, hypervisor, guest machine, and guest OS. In some cases, the hypervisor is the host OS. So the host machine is the physical machine that will host everything. It is a server or a cluster of servers. The host OS is the operating system that will manage the interactions between software and hardware. It can be a proprietary system like ESXi, or it can be a Windows server having the role of Hyper-V. As for the hypervisor, the hypervisor is the software that will manage the resources and allocate resources to VMs and emulate the CPU and memory and hard disks so that the virtual machines can run as if they were independent machines. So once the machine is created, it is the guest machine. It is hosted on a host. This is why it is a guest. And it holds a guest OS. The guest OS will then operate as if it was a normal computer. However, it is not a real computer, a real physical computer. It is a virtual computer. There are two types, basically, of virtualization, which are bare metal virtualization and hosted virtualization. But what's the difference? In bare metal virtualization, which we can see in the top picture, the hypervisor is directly installed on the hardware, which is the case in VMware ESXi. The operating system is the hypervisor itself. So what it does in this case is that it both manages the interaction between software and hardware, what an OS does, and it allocates the needed resources and emulates the CPU and the memory to the VMs. So in this case, the hypervisor manages everything in terms of software. The second type of hypervisors involves the utilization of a host operating system. In this case, the hypervisor can be installed alongside another application, just like the case in VirtualBox or VMware Workstation Pro or Hyper-V. In this case, there is an operating system installed on the server. It manages everything. On top of the operating system, there is a hypervisor, and this hypervisor takes care of the virtual machines. The two types are similar. However, the second type involves an installation of an operating system between the hardware and the hypervisor. Traditionally, in the history of the development of IT, the traditional way, the non-converged way, involved a connection between a server and a storage. Then it moved to the converged way, which involved the server connected to a group of switches, and then the storage. Then came the hyper-converged, which involved a server containing both storage and server, compute and storage. And then came cloud storage, which contained everything and made the computer act as if it was a thin client. So no processing power will be taking place on the client computer. Everything will be on the cloud, on the servers. The next definition of cloud computing is cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computer resources, for example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with a minimum management effort or service provider interaction. So this provided what the business needed. In this case, we can rapidly scale. We can create servers without the need for physical servers. We can scale these servers, add CPUs, remove CPUs, add RAM, remove RAM, increase storage, decrease storage, add multiple network cards on the same VM on the cloud. So basically, the management for IT resources was reduced by making it automated using specific servers on the cloud with minimal effort. So there are three types of cloud. Actually, there are four types of cloud. The type that is not mentioned here is community cloud. However, the term is not always used. This is why we mentioned only three types. The first type is public cloud. In this case, the cloud is public to everyone, just like Azure, just like Google Cloud. A third-party company or a cloud provider will make a cloud infrastructure and then make it public to everyone. This cloud can be used by consumers and end users, and it is not related only to one company. The private cloud is a cloud that is on-premise or designed only to one company. So in this case, suppose we have a company that needs a cloud just to itself. It can create a full cloud made online on the internet. However, only this company can use it. An example of this is Google Cloud and how they created the cloud to get what they need. And then because the cloud was so successful, they made it possible to be accessed from the public and made it and called it Google Cloud. The hybrid cloud is a mix of both. So you can have a cloud that is either replicated or partially on-premise and partially on the internet, or on other premises, or on a cloud provider's infrastructure. Basically, the public cloud is offered always by third-party providers and is available to everyone and scalable and convenient to the businesses. The private cloud still requires traditional data centers and maintenance. The hybrid cloud is in between. Why using public cloud or private cloud? It depends on the business need. It depends on the security concerns. For example, banks might need to use hybrid clouds or private clouds. Hospitals might need to use hybrid clouds. Normal companies with non-critical data can always use public cloud. We will talk later about the security concerns of the cloud. Before we elaborate more on the cloud, we need to understand some characteristics of virtualization. Virtualization is always partitioned, which means that if I have a server with 10 CPUs and 20 gigabytes of RAM, virtualization enables us to divide these services, these resources, and make pools of resources available to each VM as per our needs. So for example, as we were saying, if I need 2 VMs, each with 1 CPU, the hypervisor will be able to partition the resources and assign and allocate every resource to the needed VMs. The most important feature is that the virtual machines need to be isolated. So since virtual machines are on a virtual layer, virtual machines should not be able to intercept each other or to access the host without special treatment or special conditions, which means that if I have 2 VMs on one host, the VMs cannot access each other and cannot access the host because they are isolated. VMs are encapsulated, which is an advantage. In all cases, if we had to reinstall an operating system, we had to go through the pain of managing and reinstalling all applications. However, right now in encapsulated environments, we can put all the virtual machines and the related files inside specific storages, which are encapsulated. And if we need to reinstall an operating system, this encapsulated environment will not be tangled. Virtualization is independent, which means that there is no dependency between virtual machines, and there is no dependency on what is running on the host. So for example, if a software is installed on the host and shouldn't be used on the virtual machine, or vice versa, all non-hardware or non-functional dependencies are independent. Portability. The importance of virtualization is that it created core files or VM files that can be taken anywhere. So suppose we have a virtual environment in Lebanon and we need to take it outside, we can just take the VM files without the need to transport physically the entire servers. So if an identical or enough processing power is existing in another data center, we can just move the VMs easily. And emulation. I think most of you have experienced emulation, specifically when trying to imitate a phone on the computer. So what virtualization does is that it creates a copy of a device, which is a virtual copy, just like BlueStacks or any application that emulates a mobile phone on the laptop. This created the possibility of testing any virtual machine, any device using virtual machines without actually owning the device. There are basically two types of virtualization technologies, which is open source and closed source. Open source technologies are available to anyone for free with the source code available, while closed source are just proprietary and native to the companies that created them. Open source software are KVM and Xen, while there are of course other software, but we'll just mention those. While closed source include Hyper-V, VMware ESXi, and Huawei Fusion Sphere. Cloud services models are divided into three main categories, which are infrastructure as a service, platform as a service, and software as a service. While this session concentrates on infrastructure as a service, we need to know how each of these services function in order to better understand what is infrastructure as a service. So the basic foundation for the cloud is infrastructure as a service. In this step, in this phase, or in this category, the infrastructure is provided in terms of compute power, network resources, and storage resources, all encapsulated by the security layer. So in this category, what the cloud provider will offer you is the infrastructure itself, the VMs, everything that you manage, but is created on the cloud provider's premises. Platform as a service includes what the service provider offers in terms of platforms and things where you do not have to manage the operating system and the installed application. However, you need to manage all the configurations, the permissions, and maybe the code of the application. We'll talk about this later. Software as a service is the area where you reap the most benefits of the cloud, where you have to manage nothing but use the application. And in most cases, software as a service can be accessed only using a browser. So regarding the types of cloud computing, if we talk about on-premise IT infrastructures, the IT administration team will have to manage everything from servers to storage, networking, virtualization, going all along to applications. However, in infrastructure as a service, the department, the company itself only needs to worry about the operating system, middleware, runtime, customer data, and applications. Because servers, storage, networking, and virtualization is taken care of by the cloud provider. So in this case, we are just like renting the infrastructure from the cloud provider instead of building our own infrastructure. This can be very handy when trying to make proof of concepts or test short-term project that need critical or complex infrastructure. So instead of creating this entire infrastructure along with the physical servers, any company can now just create an infrastructure out of scratch with just a click. If we still have time during the end of the meeting, we'll try to create a virtual machine and see how it works. In the platform as a service, the company itself only need to worry about the customer data and the applications. However, servers till runtime, servers, storage, networking, virtualization, operating system, middleware, and runtime are taken care of by the cloud provider. Speaking about software as a service is where we reap the reward of cloud computing. Everything is taken care of by the cloud provider. An example of this is using an email, just like Gmail or Outlook or Hotmail. Technically, we don't have to worry about anything. All we have to worry about is just not giving our password to anyone. We can access the email from a browser. This technically reduced the cost of IT a lot, because right now an IT does not have to create an entire exchange infrastructure and can just use the cloud software provided by the cloud provider. To better understand the difference between the three types, we will take two case studies. The first case study is storage. So in infrastructure as a service on Google Cloud, we need to keep in mind that the cloud divides the resources into three main categories. The first category is compute, the second category is network, and the third category is storage. So instead of just like our laptops or computers, instead of having everything into one machine, the cloud segregates the resources to make better use of them and to make better virtualization and segregation. So what happens is that there are servers that are made just for computing, just like CPUs, TPUs, and other processors. All that these servers have to do is process. They only process data. On the other hand, we have the networking layer, which involves switches in the cloud provider's premises, software-defined networks, and firewalls. Then we have the storage, which is a bunch of servers that are only responsible of taking care of the storage. In this way, the cloud providers can better deliver faster services and more convenient services. And in this way, we can give the same service to anyone according to their needs. So suppose I need a backup on the storage once per year, and another person needs a backup on the storage once a day. So I can be given a hot backup and a hot site storage, and the other person can be given a cold site storage. To make this possible, cloud providers had to split the three elements, which are compute, network, and storage, as they are being used right now. So one of the elements is storage, and in Google Cloud, it is called Google Cloud Storage. Suppose I need to maybe create a storage and put a file on this storage to be shared to other virtual machines. I can create something called bucket on Google Cloud Storage. However, what this bucket does is just it creates a storage and tells me how to access the storage. It does not manage what I do with the storage. On the other hand, we have a Google Drive, just like SharePoint. What Google Drive does is that it manages everything I do with my files. It hosts the file, it gives me an interface to access these files, and then it manages the permission so that when I give permission to anyone else, Google Drive has to take care how they enter and access these files. Additionally, Google Drive can offer me Google Docs and Google Slides and Google Sheets, and then add history inside them so I can check what anyone did when accessing these files. In the case of Google Drive, Google takes care of everything. I just have to take care of accessing the service using a browser. So this is software as a service, because the service that Google is giving me is the software itself. While in the first case, in the case of the bucket, or in the case of the virtual machine hard drive, Google just gave me the infrastructure. They gave me a hard disk or a bucket, which is technically a hard disk, and they told me, you have this hard disk, do whatever you want with this hard disk. This is infrastructure as a service. Okay, so in the second case, we will go deep into what the differences between the services are. In the first, we will talk here about a web server. Suppose I want to create a website. Traditionally, we had to create a server, a physical server, install Linux or Windows on this server, and then install Apache. And then on Apache, we have to put the files, which are the HTML, CSS, PHP, or anything else. Once we put these files, we had to go to the firewall and route the traffic to this server and take care of the security of this machine and the security of the code. So this would cost a lot to be used by anyone who wanted to create a website. So it needed high expertise, and it needed very, very intensive IT knowledge. When the cloud came, we can create an infrastructure using infrastructure as a service, a virtual machine. And on this virtual machine, we can put Apache, we can install Apache, and put inside all the HTML files. In this case, we reduce the cost of using physical machines, and we reduce the expertise needed to manage and deploy these machines. However, we still need the knowledge of installation to add the applications needed, for example, Apache or PHP. And then we had to configure our website. The first two are infrastructure as a service. The first one was on-premise, while the second one was on the cloud. However, in the cPanel case, we are talking about platform as a service. So what cPanel does, it tells us we have the infrastructure, we have the installation, we install the application, we installed Apache, we installed PHP, any version you need, you can specify it. All you have to do is go to the FTP manager and place your files there. So what happens in this case is that we eliminate the need to have IT expertise, we eliminate the need to have system management expertise, and then all we have to do is just have software development expertise to put the files related to the websites on the server. Then came software as a service. In this case, we will talk about WordPress. Suppose we are going to WordPress.com. We can just, or Blogger.com. We can just create an account and then create a website. So WordPress told us, hey, I have my infrastructure, you can use it. I have my platform where Apache or anything else is installed and PHP is installed. You can use it. And I also have my software, which is WordPress. You can use it too. So right now, you don't need an FTP manager. You don't need anything except your browser to log into WordPress.com and just edit some fields in the website where the software is ready, the platform is ready, and the infrastructure is ready. In this case, you don't need any expertise. You just need to be someone who has a vision about creating a website and knows a little bit of marketing and photo editing and blogging. However, with the cloud comes the shared responsibility model, because as we said, some say that the cloud is someone else's computer. So here there are two types of concerns. The first concern is that where are my files being placed? And the second concern is that if the cloud provider manages my security and protects me, do I need to do something or am I fully protected? If I need to do something, what do I have to manage and what does the cloud provider have to manage? In order to better understand this, the shared responsibility model was made and was agreed upon so that we decide who should take care of what. So here we will talk about client data, client accounts, IAM, which is identity and access management, apps configuration, along till data center. So in infrastructure as a service, the cloud provider has to manage the security of data centers, physical networks, and machines. However, the IT administrators or cloud administrators need to manage everything from the network configuration up until client data. What does network configuration mean? So we spoke about the three layers of cloud computing, which are compute, network, and storage. So in the network category, we have to decide who has access to what in the network. Suppose I have two VMs and I want to separate them. I can create firewall rules to divide them, or even better, I can create virtual private connections and virtual private networks. I can create, once I create VPCs, I can segregate the network that I have on the cloud and create firewall rules between machines and between networks. And even better, I can create my own firewall in infrastructure as a service on the cloud and let it manage the VPCs. In the platform as a service case, the cloud provider manages the security of the data center up until the dev environment. And we have to manage everything else. So it manages the security of its applications, of its environment, of its installed platform. So suppose that the platform as a service is offering me a cPanel. If a vulnerability is detected in cPanel, it's the cloud provider's responsibility to fix it. Anyways, we don't have access to it, but it's the cloud provider's responsibility, and he should be committed to fixing it. And on this basis, we have the trust in the cloud, so we can put our data on it. Everything else in the application that I am hosting on this platform is my responsibility. So if my website is vulnerable in a platform as a service, it is my responsibility, and I should fix it. And it's called here a shared responsibility model. So I can't just leave it and say it's on the cloud, because true, it is on the cloud. I am protected by the cloud provider, but I'm protected in the things that he manages. While in the things that I am managing, I am also vulnerable. In software as a service, mostly everything is managed by the cloud provider. However, I have to take care of the configurations of the applications, of the IAM, and of the accounts. So suppose the least case we can talk about here is the passwords of our emails. So Gmail or Outlook are supposed to protect our emails from being hacked. However, if I write the password on a paper and stick it on the screen, it's not Microsoft and Google's responsibility to protect it. From here comes the shared responsibility model, because it shows that we and the cloud provider are responsible of protecting the environment. Okay, this is the cloud, but what are the characteristics of the cloud? As defined by NIST, the National Institute of Standards and Technology in the USA, the cloud should have the following characteristics, which are on-demand self-service, broad network access, resource pooling, rapid elasticity, measured service. What is on-demand self-service? Suppose I have an account on the cloud, okay, and I need to create 5 virtual machines. I don't have to send an email to Google Cloud or to Azure every time I need to create a VM and tell them, hey, I need to create 5 VMs with the following specs. And maybe they don't understand it, so they reply with an email, do you want 5 CPUs or 1? So on-demand self-service means that I can create virtual machines on my demand without the need or with minimal need of intervention by the cloud provider. So in this case, I can log into my account. I can go to the section where I can create or manage instances of virtual machines, and then I create them myself. I can decide what to do with these machines and how much resources to allocate to them. And based on this decision that I take, I will be billed. I will be billed based on how much I allocate, pay as you allocate in infrastructure as a service, and pay as you use in platform as a service and software as a service. So in infrastructure as a service, if I allocate 1 CPU for 8 hours, I will pay for what I allocate. While in software as a service, if I use 5 gigabytes of data, I can pay for these 5 gigabytes of data. Or if I take a subscription of 10 gigabytes per year, so I'll pay it how much I use. Broad network access. So the cloud needs to be accessed from anywhere by anyone, and this is the main advantage of the cloud, is that if I have the servers on my premise and I had an internet connection issue, no one will be able to access my cloud, my applications. However, if I put them on the cloud, they are online, they are on multiple redundant sites, and they have broad network access, which means that they are online and available to everyone, anywhere, anytime. Resource pooling. We've spoken about how much resource allocation is important and how wasted resources can cost the business. So in resource pooling, we create pools of resources. For example, a pool of computing power, or a pool of storage, or network resources. So once resources are pooled, we can better use them in clusters. So what happens in here is that, suppose I have 5 servers and I utilize 80% of the memory of these servers. And then I needed to create a VM. However, this VM needs 40% of, suppose we have 5 servers, each server has 100 gigabytes of RAM and is utilizing now 80 gigabytes of RAM. So I have 20 gigabytes of RAM on each server. Suppose I need a VM now that can take 40 gigabytes of RAM, and I don't have any server with 40 gigabytes of RAM. So now I don't have to move VMs from one server to another to create this virtual machine. All I can do is create a resource pool in a cluster that shares the processing between servers, and I can split the memory on several compute servers in order to better utilize the memory available on each server and monetize it in a better way. Rapid elasticity, which means that we can scale the VMs that we have or the resources that we have based on our needs in real time in a fast way. So suppose that the LIU's website is being used in every day with 5,000 visitors, and just in the week of exams, there's a peak of 20,000 visitors, and the resources couldn't handle all these visitors. So what can be done is scaling, automatic scaling, and rapid elasticity. In this term, the VM can replicate itself several times in order to give access and give the needed computing and storage and network resources to the project or to the website. And then when the week of exams is over and the traffic is decreased, it will automatically return to its initial reserved resources and continue working normally. Measured service, in this field, we talk about what is spent and what is used. So cloud computing is a little different from physical servers in one thing, is that if you need to create a physical infrastructure, you know what you have to pay for. Suppose you need 5 servers, 5 switches, and 1 NAS for backup. You calculate the cost of this material or equipment, and then you buy them. However, it's not the case in cloud computing, because cloud computing can vary. You pay for the traffic you use, you pay for the storage you use, you pay basically for everything you use, and it's metered based on how much you use. So if you remember when we were kids and our parents used to tell us to turn off the light before we sleep to reduce the utilization of electricity, this is how the cloud works. So if you don't need a VM at night, you have to turn it off not to pay for it, because you pay for everything you use. Additionally, cloud providers must provide the users with logging services, monitoring services, and billing services in order to tell the client everything that happens with these servers in terms of monitoring the health and performance of the servers, and also to monitor the billing and the usage of the servers or services. What are the advantages of infrastructure as a service? The main advantage is that you pay as you go. So if you can't afford to buy a big server to put your website on it or to put your application, or maybe you are an engineer that needs to run machine learning models to study some phenomena, all you have to do is, instead of buying one big server or one big laptop that have a big VGA, you can just allocate resources on the cloud and pay for the resources that you use. So suppose you need to train a machine learning model which needs 2 days for training. You don't have to buy an Omen or another laptop that has the capabilities to train the machine learning model. You just have to go to Google Cloud or Azure and just use the machine learning models that they have. Additionally, you can use tools offered as software as a service, just like Google Colab. Reduce capital expenditures, which means every company has a team of professionals that manage their infrastructure. However, this team is always repairing or always monitoring the physical servers that they have. When we go to the cloud, we reduce the capital expenditures in terms that we can use these professionals in things that are more efficient than just monitoring the servers or fixing the problems that we have. So instead of worrying about what the server is, what's the problem with the server right now, we let the cloud provider worry about it, and just we worry about something else, maybe research and development, or maybe innovation, or maybe the organization of our applications and platforms. Dynamic and fast scaling, we talked about this, how the server can scale dynamically based on how much resources are used. So we can create rules. If the CPU reaches 90%, add more CPUs, or if the CPU reaches 50%, remove some CPUs. Increased security. Since we are on the cloud and on the cloud provider's premises, we are protected by the environment of the cloud provider. Just like in the shared responsibility model, the cloud provider has to protect some of our infrastructure, and we have to protect the rest. If the entire infrastructure is on our premises, we have to protect everything. Reallocate IT resources, just like reducing capital expenditures. instead of owning physical servers, we can spend the money on something else. And instead of spending money on spending employees time on managing the servers, the same employees can spend their time on something else, which is managing the relation with the customers and their IT needs. Reduce downtime. The good thing about the cloud is that it's a big environment and it's almost anywhere. So suppose Azure just opened edge zones in Dubai with plans to open somewhere else. So in this case, this will create the opportunity for us to create duplicate servers or duplicate services. So if I have my server on the same cloud both in Lebanon and in the USA, and Lebanon's suppose that Google has or Microsoft has a data center in the USA and the data center in France, and suppose that the data center in the USA just got down, so the data center in France can go up and running. The same thing is that if I have multiple resources on the cloud and one resource for a software reason maybe or a hardware reason is damaged, I can just move on the other one, reducing the downtime. And since the processing power is higher on the cloud, I can just back up and restore everything I have in a better way. I can have faster recovery point objectives, and I can have lower times of loss. Reduce deployment time. If I need to set up a physical server, I need minimum 1 hour, and if I have to set up a server on the cloud, I need 2 minutes. So in this way, the cloud have reduced the time needed by professionals to create or deploy new environments. In this way, companies can test new things on the cloud, which they couldn't test before because they were too busy creating the environment for this deployment. Most known providers of cloud computing infrastructure as a service are IBM, Microsoft, AWS, which is Amazon Web Services, Oracle, Huawei, OVH, and DigitalOcean. To summarize the benefits of the cloud, we need to mention one thing, is that although internet connection is not a barrier to the cloud, the slow speed of internet is a barrier in many countries, such as Lebanon. So we all know that the cloud is not one server. So suppose I'm using Microsoft Cloud. Microsoft Cloud is not one computer or one building in the United States or any other country. The cloud is many computers in different countries, all connected with underwater cables passing under oceans to create one big virtual cloud. And they called it cloud because the cloud isn't one thing, it's just vapor. So the cloud is the internet, the entire internet. And what this thing does, it allows us to have first duplicated servers, duplicated sites. I can create one machine in many regions with copies in many regions. So if one region fails, the other region will be up in no time with no downtime. Additionally, we can create several copies of our websites with several snapshots. With the high computing power available on the cloud, in case a software issue occurred on our server, we can just restore a snapshot in seconds. The thing that stays a barrier is the latency in the cloud. Because if a server is located in France, the traffic needs some time, which is relatively small, to get from Lebanon to France. So in cases where we have to utilize some basic cloud services to make teleoperations and telesurgery operations, the latency can be critical and life-changing in such situations. And if you want to enable business objectives such as cloud VR or drone driving over the cloud or the metaverse itself, latency can be a game changer. This is why edge zones were created, and Azure was a big player in edge zones. So technically what they did is that they said that if the latency is caused by the distance we have, because our technology is limited in terms of speed, let's take this data center and place it next to you. So they created edge zones. So the same infrastructure that Microsoft has is all connected to one edge zone that is next to you, and you are just connected to this edge zone. So right now, Dubai is connected to the edge zones that are in Dubai. So this creates a big achievement in terms of latency and a big achievement in terms of security and compliance, because some countries enforce the companies to keep the data inside the country, just like Europe and recently the Emirates. Companies had to create edge zones to both reduce latency and um, be compliant with the laws of the countries that they have clients in, and keep their data inside these countries for privacy reasons. So edge zone went further, and we had private edge zones. So if you have super critical data and you can't share it to anyone, you can implement an Azure Edge Zone inside your data center, which is something similar to the private cloud. However, it has more support from the cloud provider, and it provides more power, and it provides more power and operations that can be carried out. And it even went further to allow end users to benefit from edge zones by implementing Azure Edge Zones with carriers. So this scenario is similar to what 5G has to offer. In the case of 5G, where latency is 1 millisecond, data can be implemented with the carrier so that university campuses or hospitals can access data in ultra reliable, low latency connections by integrating the servers and the cloud with the carrier. So suppose that I have a connection with Google. The connection has to pass over 4G, first by alpha and then by the servers of internet providers, and then go to the destination that I need. If this destination is directly put in the servers of alpha and touch, I will have a very fast connection, and this leverages the power of edge zones and the cloud. So in summary, the cloud has to offer many more advantages than we imagine. Unfortunately, we do not have the right time to elaborate more on infrastructure as a service and the cloud, because it's an introductory meeting. I hope you enjoyed the meeting, and we will have a small trial of creating one VM and infrastructure as a service. So I will go to Google Cloud, and then I will browse to the compute engine, which hosts the virtual machines, and then I will go to the VM instances. So suppose I have to format a laptop or reinstall Windows on a server, or install Linux. I will need time to prepare an installation media, and then I will need time to create to assemble the server physically and wire it. On the cloud, we can just create an instance. I can select an instance name. So for example, let's call it demo VM. I can select where the region of the server will be, and each region will have a specific cost related to the requirements of installing my VM in this region. So in this case, we will choose maybe US West 1. Okay, I can choose which CPU I need and what are the resources that I need. And I can choose the allocation of CPUs and memory, and I can fully customize it. I can also select the platform that I need and which CPU should be installed based also on my need. I can add GPUs. I can select between CPUs optimized for compute, CPUs optimized for memory, and CPUs optimized for specific operations. Once I choose the resources that I need, I can choose the boot disk with the OS. So suppose I need an Ubuntu machine with a standard persistent disk, 10 gigabytes. Okay, so I chose Ubuntu here. Okay, so I can select some firewall configurations before creating the virtual machine, or I can leave everything as is. The thing is that we need to be careful. In some cloud providers, some settings are not changeable after creating the VM, such as the network interfaces in Google Cloud. So we need to make sure that we add the interfaces that we need. However, it's very easy to change by creating a snapshot of the disk, or maybe moving the disk to an entire VM and running the VM just like it never stopped running. Okay, so here Google will allocate an IP address, and I can add a public IP address that is static. Okay, so after creating the VM, as you can see, all the cost and the estimation of the cost is displayed by Google. The same applies for Azure and IBM and Oracle and other providers. So here the VM is being created right now. Meanwhile, we can see that we also have options to manage firewall rules. If we go to VPCs, inside the PC network, I have the option to manage all the routes and all the firewall rules that govern how the traffic is passed to my server. So it's just easy to create the firewall that I need to protect ingress and egress traffic. Ingress is what comes to my server, which is incoming, and egress is what goes out of my environment, which is outgoing. So I can allow and deny anything that I need, create routes between my VPCs, or maybe create VPC networks. So here the VM was created in less than a minute, and I can SSH this VM directly. So in the case where I need a server to carry out an operation that needs 1 hour, instead of just reinstalling an operating system on a server that I have and jeopardizing the operations of the business, I can just create one server, carry out the operation, and then delete the virtual machine. So maybe I can ping google.com, make sure that everything is connected. This VM is a standard Ubuntu server that can run anything that a physical server can run. It was created by a few clicks. And now to save cost, we can delete the VM. So as you can see, cloud computing made it easier, made it faster, and more convenient to utilize the resources that are already existing on Google Cloud's environment in a way that enables businesses to make better use of IT services with lower costs. Finally, I hope you liked the presentation, and does anyone have questions?
Thank you so much. Thank you. بس كان في حدا عم يسأل إنه how we can open this cloud platform.
اوكي بدكم تفوتوا على ان كيس انتم نقيتوا تشتغلوا مع جوجل او مع ايجر، اللي بدكم تعملوه هو ان بدكم تفوتوا على بحيره جوجل cloud.google.com. اوكي، بتخلقوا اكونت عليه. اول مره رح تضطروا تدفعوا $1 لحتى يتاكدوا انه الكريدت كارد تبعتكم فاليد. من بعد ما تفتحوا الاكونت بيطلع لكم $300 ترايل اكونت، يعني فيكم تخلقوا في امات بقيمه $300 بالفري تير. يعني مثلا ما فيكم تخلقوا ويندوز ماشينز، ما فيكم تعملوا شيء معين، ما فيكم تستعملوا جي بي يوز. في اشياء بالفري تير فيكم تعملوا تيستينج عليه، فيكم تشوفوا شو اللي عم بيصير، كيف الكلاود بيشتغل، تخلقوا في امات انتم تجربوا فيها وتعملوا كونكشن بيناتهم.
اوكي، كان بعد في سؤال تاني is our computer vision considered as computer virtualization.
as شو؟
computer virtualization.
ايه اكيد. كمبيوتر فيجن هي تايب اوف ماشين ليرنينج بري تريند مودلز. يعني اللي بيصير هلا انه بيقدروا، هلا اوريدي صارت انه جوجل كلاود واجور عندهم اللي بيعرفوا بالماشين ليرنينج نحن بنعمل تريننج لموديل. يعني اللي بيصير انه انا عندي موديل وعندي تيست داتا سيت، بعمل ترين للموديل على هيدا التيست داتا سيت. بس لحتى نخفف الاعباء والبروسيسنج باور نيدد بهالاوبريشن، الكلاود بروفايدرز اوريدي عملوا هالتريننج قبلنا. لنفرض مثلا اذا بدي انا موديل بيعمل ديتكشن لكات ودوج، جوجل اوريدي عملت هذا السيستم ومايكروسوفت اوريدي عملت هذا السيستم. انا بس اللي علي اعمله هو استعمل اي بي اي ضمن سوفت وير از سيرفيس لحتى هذا الاي بي اي هو يرد علي. ساعتها ببعث له انا صوره وهو بيرد علي هذا شو.
اوكي، ويمكن في خليل صالح عنده سؤال او علي الاحمد.
You can access it by IP حسب انت كيف بتحدد الفاير وول رولز. يعني اذا هو مثلا ويب سايت، شفنا نحن عم نخلق الفي ام انه في عندي اوبشن انا عم بخلقها انه حط allow HTTP and HTTPS access. في كمان انا من الفاير وول بخلق رول انه كل شيء انجرس، يعني incoming، كل شيء انجرس ترافيك على البورت 443 عامل له allow على هيدي الفي ام، بحط لها ساعتها نتورك تاج، وبحط انه كل شيء incoming على هيدي النتورك تاج to be allowed.
علي حمود عندك سؤال؟
سوري بس كرمال خليل عم بيسأل which one can I use for free. الاثنين عندهم فري تير. فري تير يعني الاشياء اللي فيك تستعملها فور فري بالترايل بيريود اللي هي ماكسيموم بتكون 6 شهور. فيك كل كلاود بروفايدرز عندهم فري تير. بدك تشوف انت النيدز تبعك وتفوت عليهم، بدها شويه ريسيرش لتشوف شو الكلاود بروفايدر اللي بيأمن لك طلباتك انت، وبتفوت بالفري تير بس بتدفع $1 عند الكل لحتى يتاكدوا انه الكريدت كارد تبعتك فاليد، وبترجع بتستعمل هالفري تير مثل ما انت بدك. ان كيس عايز مساعده فيك ترجع تحكي معي.
علي بدك تسأل شيء؟
يس، انت حكيت من قبل شوي انه انه في عدد معين من السيرفرز، كل سيرفر بتعمل نقول وحده بروسيس داتا، وحده فاير وول ونتوركينج، وحده ستورج. سؤالي انه هول السيرفرز بيكونوا عاملين كونكت مع بعض ولا كل وحده لحالها؟
اكيد. مثل ما قلنا نحن انه النتورك مفصوله عنهم. سو اذا انت عندك سيرفر او كلاستر سيرفرز بالاحرى للكمبيوتنج وكلاستر سيرفرز للستورج، اكيد هن موصولين ببعض يوزنج فايبر كونكشنز على الارجح. بكمان كلاستر نتوركينج، يعني هي اذا بدك لايرز فيك تعتبرهم، وهن كونكتد بين بعض بكلاستر نتوركينج كمان. يعني هي الفكره المعموله بطريقه انه مش شيء واحد كونكتد على شيء واحد، بس لاير كونكتد على لاير، بطريقه انه اذا في element واحد من هذا اللاير بطل ماشي، كل شيء باقي بضله ماشي وبيعمل فيل اوفر على الباقي. ما بعرف اذا جاوبتك على
هو
السؤال.
بيبين نقول اذا شيء مش ماشي، بيبين انه والله من هيدي المشكله. انت قلت لي هن كلاسترز مع بعض، مش بيصعب علينا نلاقي نحدد وين الوجع وين المشكله، بس يكونوا كلهم مع بعض.
سوري، كان حدا عم يحكي معي عطشت عندي الكونكشن.
يس، كنت عم بقول
علي.
انه بس يصير في عنا مشكله، مش بتصعب علينا نلاقي من وين المشكله، اذا كان وقتها اذا كان من البروسيس او من الانفراستراكشر، اذا كانوا كلاسترز مع بعض.
الحلو بالكلاود كومبيوتنج وبهالمواضيع بهالانفراستراكشر انه انت الموضوع سيمليس لك. يعني انت ما بتعرف شو عم بيصير من ورا. جوجل هي عم تهتم مثل ما قلنا قبل انه السيرفرز والانفراستراكشر من ورا الكلاود بروفايدر هو عم يهتم فيها. اذا في شيء كان داون عنده انت ما حتحس فيها، هو اللي حيروح يهتم، هو اللي حيروح يظبط. اكيد في كتير سيرفرز بتوقف بالنهار، اكيد في كتير هارد ديسك بيتغيروا بالنهار، بس انت بالنسبه لك السيرفر بعده ماشي، لانه الانفراستراكشر مثل ما هي كانها اذا بدك لاير كامل ماشي من فوق، ومن تحت المانجنج تبعه الكلاود بروفايدر بيهتم فيه. يعني شو بيصير بالكونكشن اذا في مثلا سويتش انتزع، اذا في هارد ديسك انتزع، انت رح تضل ماشي عندك لانه في ريدندنسي على الكلاود. however اذا انت صار شيء عندك على ليفل الفيرتشوال ماشين، هذا اللي حتحس فيه. بس كل شيء بيصير بقلب الانفراستراكشر تبع جوجل او تبع مايكروسوفت انت ما بتحس فيه ابدا.
كتير حلو. يس، ثانك يو.
ايوه.
Okay guys, حدا بد عنده شي questions؟
No,
Yes.
thank you.
Okay, thank you so much. Thank you, Mr. Joe. It was
Merci
great
لكم.
event. Thank you. Thank you for your attendance guys. هنبعتلكم هلا الفورم، بليز لازم تعبوه، وما تنسوا بكره الميتينج والأحد كرمال تاخدوا your certificate. Okay. Thank you so much. هحط لكم اللينك تري تبعنا موجود all our social media فيسبوك انستغرام واتساب جروب كله موجود. Hope you enjoy today's meeting وبشوفكم بكرة أكيد.
Okay, thank you.
بس أخبركم إنه معكم بس 20 minutes لتعبوا الفور.
Okay, ماشي.